So I would now like to give the floor to an operator, someone who manages maritime safety. His name is Olivier Texier. He's Deputy Vice President of Safety, Security, and the Environment at CMA, CGM, excuse me. So they work on safety and security. Currently, you are supervising a fleet of approximately 110 container ships. So you are the perfect person to tell us about the operator's point of view. Truly, sincerely, I thank you very much for accepting to be with us today and sharing your viewpoint with respect to challenges and dangers for container shipping. I'll give you the floor.
Thank you very much. Thank you for inviting me. I'm delighted to take part and to share a ship owner's viewpoint. There are many things that have already been said that I will be addressing from a more pragmatic point of view, from a shipping company point of view. I'm going to be sharing a presentation. So good morning to you all. I'm going to be talking to you about the container safety logistic chain. I work for the CMA CGM shipping group. So we mainly deal with container ships. I'll be dealing with the logistical chain starting from the beginning. So the beginning of the chain is our customer. Now, as you know, all containers that are shipped today are done so on the basis of a declaration. So there's the bill of lading. So the shipper or the customer will give the list of all the goods that will be loaded. So then these goods are packed into the containers. And so the goods declaration, for legal reasons, we don't open the containers, but it's important that there's this declaration for a reason for fire hazards, but also questions related to drugs and so on. On the declaration, in fact, there are very many misdeclarations, whether it's in terms of quantity or quality. So there's the question of whether these are dangerous goods or not. This is not always necessarily very clear. Sometimes there's a misdeclaration due to lack of knowledge that can occur fairly frequently. Secondly, it can be for commercial reasons, because of course it's less costly to transport non-dangerous goods than dangerous goods. The name of the packaging actually has its importance because there's the question of movement inside the container that can have various impacts. The weight, so I'm sure everyone's familiar with VGM, the VGM regulation. So the idea is to be able to control the weight before the container is loaded. There is the possibility of a declaration by the loading party at the terminal before the container is loaded. Now, there can be differences in weight. Now, given the volume and the gigantic size of ships, as has previously been mentioned, if there could be, so if a container may, for example, weigh 30 tons, a difference of 30 tons is not going to make a big difference for a ship, but if you multiply it by the number of containers, then it could have a serious impact. So these parameters are fairly difficult to control and can have an impact for the crew and for the ship. So our role is to educate. Even the word may seem a bit strong, but really to educate in terms of regulations and logistical practices. Having said this, most of our customers are of course honest and play their part, but it's important that we remind them of these issues. The second link in the chain is the terminal. So when the container arrives at the terminal, it will be loaded onto the vessel. So there will be a loading plan, which needs to correspond to the reality on the ship. However, there are sometimes differences between the final plan and the actual situation on board. In most cases, when the crew does their rounds, they pick up on these differences. If, for example, the containers are stacked too high, that can have an impact on visibility, for instance. If there is a really obvious difference, it will be picked up on visually. But it's not always visible, so that can be sometimes something that's a bit difficult. And the second point in terms of terminals, in terms of lashing on board, they are done by onshore personnel, so stevedores. And so with the putting in place of these lashing rods. So this is all checked before the ship leaves. But given the very large size of these vessels, if you've got 24,000 containers, for example, and I don't know how many bays and rods to be checked, that does take a considerable amount of time. So mostly if there are anomalies, they are corrected before the ship leaves. However, there can be examples, for example, of the lashing rods being in place but not sufficiently secured. We've had very many cases recently, in particular with American ports, when the checks have been implemented before leaving, but there have been major differences, and so we've had the ship return to port and the differences be corrected. Because there are nautical risks. So now on to the vessel and the crew. There are various regulations. I'm going to look at the three main risks today on board. First, has already been mentioned, is firefighting capacities. For CMA, CGM, the major incidents we've had recently have involved fire. So there are regulations in place in terms of informing the crew and so on. So we try to go further and work together with BV, Bureau Veritas. I would like to take this opportunity to thank. And so we've put in place class notations that go beyond existing regulations. And there's also the question of the quality of the goods that we take on board. Our shipbuilding standards, because we build our own ships, in these standards, we integrate these factors from the beginning. So we have, for example, fire extinguishing pumps that are superior to the regulations that are installed from the onset. Training crews is another important point. In 2021, it's something that's is going to be really a point of importance. We're working with the French Navy to have onboard training. Of course, with COVID, that complicates the situation for onboard training, but we're trying to develop this as best we can to improve the quality of training for our crews, because a fire needs to be extinguished within the first few minutes, and if it doesn't, it can get far more complicated. Next, so monitoring of onboard operations. So all our onboard operations are tracked. Today we have between 300 and 350 vessels that are chartered as well. So we track these vessels to optimize routes, to improve fuel consumption, but also for safety reasons with relevance to weather conditions. Recently, we've had some fairly complicated weather conditions which have contributed to recent incidents. Luckily, not with us with CGM. We have loading software that takes into consider all the capacities of the vessel, and it's dynamic software. So it's a kind of an evolving manual that lists all the strains placed on the vessel by the containers. We saw in the previous presentation by Mr. Rubens de Servance the impact, the physical impact on the vessel. I'd also like to mention Octopus, which is an onboard software program which calculates, based on all the vessel parameters, it calculates parametric rolling. It's quite a complex phenomenon. I'll be showing you a picture just after. And the third point is the environmental impact. So, of course, this includes the loss of containers overboard, which I will be coming back to. At CMA CGM, in 2019, we only lost one container, so that was a very good year for us. In 2020, we lost 40 containers off a single vessel, just off Australia. So then there was the question of searching for these containers, which was a real challenge. So the first point was firefighting. So on this slide, I show you the kind of firefighting capacities we have on board, and feedback as well from other ship owners for the kind of equipment that they use. So you can see on this slide that the standard includes various aspects. So, for example, PPE on board and respiratory devices, on station, onboard fixed equipment with water mist lances, equipment in the accommodation, and also detection equipment. In order to provide an effective response, it's important that we can detect, so smoke detectors for detecting when a fire may be about to start or has started. My second point is the optimization of operations. So we have an operations center that you can see on this slide. So this is where the ships are tracked, and we also monitor the weather conditions. in the bottom image, you can see a ship's trajectory in the Atlantic, and we amended the route northwards to avoid an area of turbulence that appeared dangerous for rolling. We've had another case recently in February, the Maersk SM, that lost containers in the Atlantic, and we have another vessel that had the same route planned, but about 200 nautical miles further south, and this vessel didn't lose any vessels. So this tracking is really an essential route in order to predict and to prevent the loss of containers. We also have the issue of containers, a collapse of a container stack on board. It's something that's not addressed so frequently. Another point I would like to address is lashing equipment. So with a typical load on board, the typical failure is related to lashing equipment. We use the cargo securing manual, and this only provides typical standard cases. In the case of the Washington vessel, we realized that we really need documents that would replace or supplement the CSM, because it doesn't cover everything. And so, of course, we need to be able to react 24/7 in the event of an emergency. My third point is the environment. So today, there's a variety of options available. It can concern anti-fouling, air pollution, it can also relate to scrubbers, to clean the fumes, as it were. Also the use of steel that's a little thinner, optimizing propulsion as well. So all these aspects are now standard on all our ships to ensure that we have green ships and reduce environmental impact. In terms of LNG ships, our objective is to reduce CO2 emissions and other pollutant emissions. To come back to fire, I mentioned misdeclarations. There are the IMDG regulations that must be complied with, which is not always the case. So a fire may occur on deck or in the holds. The situation's different and will require different firefighting equipment. Ideally, we should avoid having human resources, so having a human response, so as not to place those operators in danger. There's also the question of how gas tight and liquid tight the holds are, and avoiding issues within the holds. There's also the question of ports of refuge. The crew will be able to respond within the first few minutes, but then if it gets more complicated, we'll need external help. So if the situation becomes aggravated, we will need shore assistance. And so the question of ports of refuge is important, and the port must be suited to receiving vessels, which can be up to 400 meters long and 60 meters wide. So the second risk relates to weight and misdeclaration. So that can lead to the loss of containers either on board or into the sea. We have a few pictures here. One of them shows blocks of marble. Now, normally, a container that was meant to be about 30 containers, we weighed some of them that were up to 45 or even up to 60 tons. The quality of the lashing bars and twist locks is also important. With an increasing size of container, or increasing weight of containers and increasing number of containers, is important that these are sufficient. We will have up to 8 lashing bars as well as the twist locks. So this is generally a very robust system. So to focus on the loss of containers, if we relate the number of containers lost to the number of containers transported, we get something like 5 times 10 to the power of -6. So it's fairly low, but having said that, every container that's lost is a form of pollution. There are actually very few ships each year that suffer this kind of event. At CMA-CGM, we have on average 1 case a year, so 1 ship involved each year. So the efforts we have made, the main effort that we've made involves weather routing, and also with our loading software, and also software that predicts the movements of the vessel. So this slide shows you a picture of the west of Australia. So this was a routing error with poor interpretation of weather forecasts. And we had winds of up to 45 knots and 8-meter high waves. And so this slide shows a study by the Octopus software where the red areas show areas of danger, taking into account the vessel's conditions, so its fuel, its onboard capacity. So you can see that the vessel was not in fact in the red zone, given its planned route. So in terms of the number of containers lost, 50 containers were lost. We are responsible for retrieving those containers. So in this instance, it was in Australia, so we used drift prediction software. We recovered 25 containers, so either washed up on the shore or at sea, and they were floating sufficiently that we could tow them. We used 2 vessels, one with multi-beam sonar, and we didn't find any sunken containers. there was some debris found showing that certain containers, when they are lost overboard, they get broken up by the sea. The containers we lose are often the outermost containers, and in most cases they are in fact empty. So 3/4 of the containers we lose in fact are actually empty. So that brings me to the end of my presentation. I hope I'm on time. Just to give you, so I hope that gave you some insight into a ship owner's point of view.